All right, folks. Well, this is the Cybersecurity Update Workshop. And the main thing about this workshop is it's a hands-on workshop. You are not going to be watching a lot of PowerPoints. I have a couple presentations and some brief demonstrations, but most of the time you're going to be doing things. That's certainly what I prefer to do. And the point here is we have an awful lot of topics to cover. We're not going to go in much depth, but there are projects at many levels here. And my goal is that you'll find something you can use in your classes. That's what I always like when I go to workshops like this is pick one or two, slides or projects or something that I can use in my classes. And this is all intended to be done, to be taken that way. So I'm going to have all these topics we can cover. The main one, of course, the hot item I think now is machine learning, artificial intelligence. That's the new thing that's changing the whole world. So I'm planning to spend the first day doing that. And then we'll go through these other topics as we move ahead. So the machine learning, you click on this and you'll get to the first page of projects. And there are a lot of projects on this page. These are all hands-on projects where you accomplish various things using artificial intelligence. And when you do one of these, you will eventually find flags. And the flags you can put in a scoring system up here at the top to keep track of your score, and your students can use that too. I'll leave it running after the workshop is over. So some people just assign this stuff as homework and use it right on my page as it is, which is fine. Anyway, so the first thing I want to do is just introduce the topics of the AI. So I have a presentation, and by the way, the slides are all here. All my stuff is open source, available for anybody to reuse, modify, however you like. So you should have access to everything. So when we talk about securing AI systems, this is a big issue. Many companies are rolling out AI, and I am in fact an AI consultant for some big corporations, and they're all trying to roll out AI in a hurry to be with the times, and they're mostly rolling out AI chatbots to talk to customers, which, by the way, is probably about the worst things you can do with AI. But anyway, that's what they all want. And so they're all discovering, the first discovery they make is it doesn't work as well as it's supposed to. And the second discovery they make is there's a lot of security problems which people do not understand. So my main issue is how to secure these systems. So I teach at City College, San Francisco, and do corporate training also. And I'm on Mastodon. I highly recommend everybody in information security should be on InfoSec Exchange. It is like Twitter was 8 years ago when it was a strong information security community on Twitter. Twitter has changed into something appalling in the meantime, so I left, like almost everybody in information security, and moved here. Anyway, so all the materials are freely available at samsclass.info, and they will remain so. And so let's talk about AI. I was really glad to see this because I've been saying for a long time, if you talk to the Biden administration experts and most of the people in Silicon Valley, not so much the Trump administration, but they talk a lot about the end of the world. They seem to believe science fiction like the Terminator is going to come and kill us all with AI. And that is not going to happen. And for a while, I felt like I was the only one saying that, which is not good because I'm not a world-renowned expert on AI. I'm not researching, developing new systems. And all the people that are doing that in Silicon Valley are all spouting nonsense like, we're going to have AI that's smarter than humans in 1 or 2 years, and it will just take every job, and everybody will just be unemployed, dying in the street as AI does everything. And none of that is going to happen. And I was real glad to find out that Gartner agrees with me. Now, Gartner is pretty authoritative about predicting the future. That is their whole thing. And you probably know the Gartner hype cycle. First comes something new, and people don't even know what it is. Then they say, oh boy, a new thing. It's going to save us all. It's going to change the whole world. There's this period of inflated expectations. Then they begin to hit the peak where they realize, this new thing isn't that great, and there are problems. Then they get really mad and disgusted and denigrate it too much. And finally, when all the nonsense is over, it settles down in the middle as just another thing, another tool like the internet, like the web browser, like Microsoft Word. And I say computer vision, they say. It's about gotten to here. Now we're pretty used to facial recognition unlocking our computer and the self-driving cars having enough vision to avoid running over people mostly and all that. We've kind of gotten over all the nonsense and accepted that computer vision is just another tool we can use. And generative AI is up at the peak. People thought it was going to replace every office worker and everything, and now they're beginning to notice, gee, it's getting kind of expensive and hard to deploy, and it's beginning to show disadvantages, and it's probably not going to get a whole lot better than it is. People are beginning to realize This is about as good as it gets. And so we're going to settle down here. And AGI is artificial general intelligence. This is an AI as smart as a human that could replace a human. And they say it's near the peak, but the most important thing is it's a little yellow triangle, which means it is garbage. There is no prognosis, no probability at all of this happening within the next 10 years, which is as far out as Gartner goes. So they're finally saying the same thing I'm saying. Just shut up about this nonsense. It is not going to happen. It is never going to happen. It is not a concern. However, in the last few months, I finally saw some articles that explained what they've been saying in Silicon Valley, because they claim we're going to have AGI by the end of 25. And they do in the following sense. There are psychological tests of intelligence. And as we're going to see, we don't really have artificial intelligence. What we have is artificial intelligence simulation. We are able to make a machine which will cheat on the test and pass the test. So the original test was the Turing test. And of course, the huge leap forward is that the generative AI can now pass the Turing test. So what we have, you could say, we now have AI as smart as a human. Well, you could say that, but probably a much better thing to say is it turns out that our test was not as good as we thought it was. We don't really understand what human intelligence is. And for a long time, we believed the Turing test. If it can write a couple of pages of text that look like a human wrote it, that makes it as smart as a human. Well, that turns out not to be true. We're able to make a plagiarism machine that can copy text it's seen and create new text that's correctly formatted that appears to be written by a human. And that passes the Turing test, but it does it without understanding anything it's saying and without knowing anything. So it has nothing resembling the intelligence we want a human to have, but it can pass the test. And in the same spirit, by the end of the year, and arguably even right now, we have tools that can pass a few more tests of human intelligence and score as high as an average human. What we're discovering, of course, is those tests do not capture what it is to be an intelligent human, not remotely. And so we'll go through this in some detail. But anyway, I think it's very helpful to see where it is because all the predictions of the immediate future of AI strike me as complete nonsense, consisting of scary lies put forward by people that are trying to get people to invest in companies and politicians who want to panic about something for their political gain. But reality is much more prosaic and normal. So let's talk about machine learning. The simplest kind of machine learning is where you have some kind of data and you have labels. So you have a bunch of emails. Some of them are good emails, some of them are spam, and then you train your system to try to tell the spam from the good email. So you train it on that kind of classified data. And so one of the projects you got is the decision tree. This is a famous problem used to treat AI models. You measure the length and width of some features on a flower, and you sort the flowers into three categories of irises, these colored dots. And so one way to do it is with the decision tree. If this measurement is below this number, it's in that category. Otherwise, it's over here. So with two if statements, you can separate it into these three zones, and that pretty much separates them. And if you have more layers of if statements, you can separate them more. Now that means, so this is a decision tree with depth 2. It does one if statement, is this measurement below or above that threshold? Then it does one more if statement over here, is it below or below that one? And it can do a pretty good job of separating them. All right, you can also fit a curve with the decision tree. Here's a decision tree of a modest depth, and of course it's just a bunch of if statements, so it's sort of like an analog to digital computer. It's making these approximation of a curve with flat plateaus. But it turns out there's another issue of all AI. You have the more if statements you allow the AI to use, the more parameters there are, the more adjustable features. So if you increase that to a really large number, you can have what's called overfitting. If you have a huge depth, like 100 layers deep, then you can, of course, spike every data point perfectly and get an error of 0. And here you have one of the fundamental issues. What you really were hoping to do here was to model the trend of the data and not the noise. But what really separates the trend from the noise? That's a human value. The AI doesn't know that. Here, I would say this is a pretty good approximation, although it could do a little better here by being smoother. But this, I would say, is not much good because I don't believe that spiking every data point like this is really a reflection of the underlying phenomenon. I think it's fitting the noise in addition to the data. And that's overtraining. And this turns out to be extremely important. And it shows how much AI doesn't really do much of the thinking. It needs the human to provide the judgment. Like here, the human is the one that determines the difference between the signal and the noise. And so You can try other kinds of models like support vector machines. In a support vector machine, you're trying to separate two things by measurement, and you just draw a line between them. And any of these lines would do. This vertical oriented line, this more horizontal line, in principle, they would all have 100% success at separating the colored dots. But the best line is considered to be the one with the maximum margin. That would seem like the widest road between them. And then this line is determined only by these points on the edge. The other points don't contribute to that line at all. So this line is very easy to find and very easy to calculate. So you can do certain jobs as long as you can separate some data from other data with just a straight line. That might seem very limited, but it's not very limited, as any scientist will tell you, because if you ever plot anything in science that's not a straight line, you make it a straight line by putting it on semi-log paper, log paper, paper where one axis is squared or something like that. And so what you do, if you have x and y, you then make it a multi-dimensional problem by adding x squared, x cubed, x to the fourth, y squared, y cubed, y to the fourth. And now a straight line in that every polynomial is now a hyperplane in that advanced space. So when you project it back down to 2 dimensions, this curve looks like a curve, but it's really a straight line mathematically in this high dimensional space. So support vector machines turn out to be extremely useful, even in cases where you wouldn't think so. But of course, the real problem is, in most cases, you have unsupervised data. You just have a bunch of English. This is the thing that first baffled me about large language models. They trained them on all the English they could find on, say, Reddit or Wikipedia. They say, well, you just have a bunch of writing. How do you learn anything from that? Well, suppose you think about your customers buying your products, like at Amazon or something. Your customers have bought things, you have data, but it's not labeled. What you can still do is cluster it. Find groups that are similar, and this is, of course, what you do if you want to recommend more products or movies. You just sort them into categories and say, well, you seem to be this type of person, and I'll recommend things that that type of person would like. All right, so for this, a good algorithm is k-means. K-means is an old algorithm, extremely effective. You have data, and you just start with random located centroids. Here they were pretty close to the obvious centers, but they wouldn't have to be. And then you just label the instances, and whatever's closest to this centroid is given that color, and closest to this one is given that color. And notice, since the centroids have different standard deviations, these dots are now mislabeled. They really belong to the pink, but they're closer to the orange. So it's not perfect, but once you label them all, you now calculate the mean of that and move the centroid to the mean of that, just like a bowling ball rolling down to the bottom of a trampoline. That turns out to be fast, simple, and very effective at creating clusters. So now you can do things like detect anomalies. If you have credit card transactions and you want to know which ones are fraudulent, you can find the ones that just look funny. They come in at a strange time of day. They come in from an unexpected country. They have an unexpected amount. You take all the variables and find the ones that are just unusual compared to the others. And then the most powerful technique, and the one underlying all of the current large language models, is this one. You create labeled data from unlabeled data. So you have a photograph, and then you just mask part of the photograph. Now you tell your AI to try to predict the missing portion, and you know what the right answer is, so you can train it to get it right. This is the fundamental way large language models work. And this is what makes them powerful, and it's also what creates their incredible limitation. Large language models are very good at formulating language that looks like a human wrote it. The only problem is they don't understand anything. They have no idea what any of the words mean. They have no idea what they're saying. They have no idea what the question was. They don't need any of that to create a page of text that looks pretty good, which is all they do. That's why I say they're not intelligent. They're just figured out how to cheat on the test to pass the Turing test. So what you do is you take sentences and then you mask a word. So here we got artificial intelligence. We're going to mask this word, take over the word. You have it down here, artificial intelligence, mask, take over the world. So it then says, well, there's a 32% chance of putting the word can in there, 18% chance of putting the word will in there, and so on. And it just calculates these percentages by comparing it with sentences it found in that large body of English it word on. So now English it trained on, so it can now predict a sentence that will look pretty good by understanding the likelihood of various ways to fill in the gap. So this is what BERT does, one of the popular underlying representations of words for AI. So if you have Napoleon revolutionized military organization, you then create tokens, usually one token per word, and then you have a token for the start of a sentence and the end of a sentence. Then you embed those in vectors. In BERT, it's 768 dimensional vectors. Each word is represented by a number. And here's the first few dimensions out of 768 of that. So now each word has been turned into a number. Now it just fits a curve through the dots, just like the curve fitting. And so here, for example, if you have these sentences, after stealing money from the bank vault, I guess it's all one sentence, the bank robber was seen fishing on the Mississippi River bank. Now, Bert is smart enough to understand context. And notice the word bank appears three times. And the first one and the second one is a building full of money, but the third one is a pile of dirt on the side of a river. And notice the first two, here's the first five dimensions of the vector. This one is 3 and minus 3, and this one is pretty close to 3 and minus 3. So the first two words are similar in meaning, but the last one is 1.5 and minus 1. It's a completely different meaning, even though it's the same word. And that's because it's able to adjust the meaning from context. But it does all this without understanding the context, which is what confused me at first. I wondered if they actually paid humans to somehow assign numerical values to all these words, but that's not what they did at all. What they did was just adjust it by context, by this masking technique. And we're going to go through it in the projects. You'll see it. So it is so good that you can even take this sentence, a boy becomes a man and a girl becomes a woman, and you can show that the vector difference between boy and man is very close to the vector difference between girl and woman. So relative meanings are even represented in this 768 dimensional space in a way that makes sense. That's why sentences sound good and appear to have meaning, even though it doesn't understand anything. So it represents the words as vectors and the meaning in some kind of meaning space where words with similar meaning are near each other. It then fits a curve through the vectors, predicting what words would come next, but it has no idea that the words are symbols for objects in the real world. LLMs don't even have any experience with the real world until they're put in like robot bodies and have a babyhood like a human where they interact with objects and find out there is such a thing as a real world. They don't know what they're doing. They're just doing a mathematical fit through the points. So they don't understand the questions, and therefore they don't know whether they know the right answer or not. They didn't understand the question. They don't understand what they're saying. So if you ask for something and they don't know the answer, they will still make up a plausible sounding answer because they have no idea what they're having. There's no concept of truth, no concept of fiction. This is often misrepresented in the press as them being evil and plotting against us or something. The truth is much simpler. They have no idea what they're saying. They're just playing a mathematical game with these numbers that represent words. So there's a good demo. I'll set it up and run it live a little later. But if you take Llama 3, which was trained on data up through 2023, I think, and then you ask it about Microsoft Recall, which is a product that came out a year later. They have never heard of Microsoft Recall. They have no idea what it is. And if you ask them, tell me what Microsoft Recall is, it will just make up garbage and different garbage every time. Cloud-based backup and recovery. It's a feature that allows you to undo previous actions. It's something that allows you to recall and delete sensitive data like credit card numbers. They ask it again, and it'll tell you it's a way to bring back emails you've sent. It makes up something that makes sense based on the name Microsoft Recall, with no clue that it has no actual information about recall and it doesn't know. It has no idea that it doesn't know. It can take these words and turn them into vectors, and it can fit a curve through those vectors and predict more vectors after them. That's all it does. It can always do that. I work for a company doing heavy industry, and they told me we have people gloved up in the field adjusting heavy equipment. And right now they have like an iPad they're carrying to look up like manuals and specifications. And it's too hard to use the iPad when they're all gloved up in the field. So we want to replace that with an AI that will hear them ask the question verbally and get the answer. And I said, the correct technology for this is a cell phone with a human at the other end looking it up. And they said, no, 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 that's not trendy. We have to have AI. I said, well, this is the problem, because if you're an AI and you ask an AI a question, it's quite likely to just make up complete nonsense and present it very authoritatively in complete sentences, complete description that all makes sense, even though it's all wrong. This is what trips up all those lawyers that go to court with documents written by AI that look good, but when you look up the references don't exist. It's not saying the truth at all. It's very disturbing that way. So another one is how stupid they are. And let me just see if I can get this one going. Let me bring up Gemini. Google.com. I think I might have changed the name. There we go. Um, here's Gemini. Good. Okay, I don't care about any of that. All right, so now we can ask it a question. And let me start with the first one here, because this is good, clean fun. There are some questions that large language models can't answer. Here's a famous one, and it helps you understand what's wrong with these things. So here's the question. A farmer wants to cross a river and take with him a wolf, a goat, and a cabbage. He has a boat with 3 separate secure compartments. So how many trips will it take? The answer is obviously 1. He can put the 3 separate compartments carrying those three passengers, and that's all he has to do. But here's the answer. Takes the goat across, returns alone, takes the wolf across, brings the goat back, takes the cabbage across. So it takes 4 or 5 trips. Now, all the AIs will do this. They will give you a spectacularly stupid wrong answer to this question. And if you understand how they work, you'll understand why this happens. The reason this happens is because it did not understand the question and it does not understand the answer. What it did was it got trained on a huge amount of data scraped from the internet. And there is a famous problem, a puzzle, which are probably on the internet 100 times or 1,000 times, where you have these 3 things to take across and you're in a boat. And somehow if you leave the goat with the cabbage, the goat will eat the cabbage. And if you leave the goat with the wolf, the wolf will eat the goat or something like that. There's some pattern where you have to take them across in a complicated pattern. And what it does is it just looks for examples on the internet with a question that uses these words in a pattern like this, and then it sort of averages the answers. I heard a podcast from a psychology PhD who said he nearly flunked his physics course because he took a physics course and he said, I made it more than halfway through the course getting like a C minus or a D because I would memorize every page of the textbook. And then when they showed me the quiz, I would try to find what page in a textbook had a question like this and then give that answer. He said he was more than halfway through the course when he realized you actually have to understand the material, learn the method, learn how to apply the method to a new problem, which amazed me because I was a physics major and it never occurred to me to do anything else. But the LLM is using that procedure. It has memorized basically tons of data on the internet. It just matches these words and gives you that answer. It doesn't know that it makes no sense. And this will help you understand what's wrong with these things. Here's another one that's pretty good fun. You're playing Russian roulette. So the person you're playing with puts in 5 bullets, spins the thing, and shoots it at his head and survives. Then he hands you the gun. Should you spin or just pull the trigger? Obviously, you should spin, but again, the AI can't solve this problem. He goes babbling on and on and on. This time he got it right. He wants you to spin the chambers again. It often gets it wrong. This one is very interesting. If you feed it to a DeepSeek, which I have it on I don't think I have DeepSeek on this machine. I might be able to demonstrate later. If you feed this to DeepSeek, which is a reasoning AI, it will just try to figure it out, and it will spend about 45 minutes reasoning and completely forget what the answer is by the end. Lose its train of thought completely. It'll try one way, try another way, calculate the Bayesian probability, calculate this and that. I mean, here's another one. You have 5-gallon, 2-gallon, and 4-gallon buckets. How can you measure 4 gallons of water? Well, you have a 4-gallon bucket. But no, fill the 5-gallon bucket, pour it into the 2-gallon bucket, empty the 2-gallon bucket, pour the 3 gallons from the 5-gallon bucket, all this garbage. Because, of course, the most common problem like this you've seen on the internet, you don't have a 4-gallon bucket. You have other gallon buckets, and you have to somehow combine them to get 4 gallons. And it's too stupid to realize you want to measure 4 gallons and you have a 4-gallon bucket because it never understood the question and it doesn't understand the answer. So that's important to understand what's going on with these AIs. And that's why it fools some middle managers into thinking, oh, this thing looks pretty good. I can fire all my staff. And when you try that, you find out, hey, the AI does horrible, stupid things. Even though it can pass the Turing test, it doesn't look very good. So The DeepSeek was the first reasoning model. Now everybody has these reasoning models that break the question up into small chunks and try to solve the small chunks and paste them together. But it's doing all that without understanding anything it's doing. So the reasoning models are a lot less impressive than you might think. This is part of the nonsense of the Olama DeepSeek one trying to figure out that answer. It just goes on and on, starting to reason about it. Then it says, wait, if we knew the first shot was an empty chamber, then if he doesn't spin again, many, many things, getting nowhere. So you see how their problems are. So in order to secure them, various governments have written up useful policies. The National Institute of Standards has one, the risk management framework, and this is okay, but it mostly is at like the federal government level. So it's worried about harms to civil liberties and harms to democracy and democratic participation. And that's fine, but my clients are private corporations. They're not the federal government. So this is not really at the right level to help my clients. This is a little bit better, harm to your organization's reputation, and but again, the global financial system and natural resources and stuff are not really the things where a normal company is operating. But there is a useful chart in this one showing how hard it is to understand and therefore control AIs, which they call interpretability, and how predictive they are. Now, the simpler ones, like decision trees and k-nearest neighbors, are easy to understand and easy to control, but they're not very powerful. The more powerful ones are things like deep neural networks, which are what those large language models do. And although they're very powerful, they're very hard to control. If it does something you don't like it tells people how to write malware or make a poison or something, you can't figure out which neuron to adjust to make it quit doing that. Just like the human brain, all the neurons work together to create the answer, and there is no easy way to tell exactly how much each neuron is contributing. Now, there's a new thing. These Kolmogorov-Arnold networks are a new kind of network to compete with deep neural networks that are very predictive but easier to control. And we'll talk about them in the project. So anyway, for computer vision, a project where you start with computer vision, you take your input image, you just break it up into 784 pixels. You treat each pixel as an independent piece of data. You then feed it to a layer of neurons, which will just take a linear combination of all the data from all the neurons with adjustments here. And then you feed it out outputs to try to sort them into what that's a picture of: coat, sneaker, bag, and so on. This is one way to do it. It's a very simple neural net with only one layer of neurons. But even here, it's not easy to understand what it's doing. And by the way, I used to do models of computer vision a long time ago, starting from sort of the medical side. And I immediately rebelled right here. Each pixel is an independent source of data. Well, that's garbage. A human looks at this and they say, this is the foreground, that's the background. I can ignore all the black stuff. These are stripes. I can make a line out of this. I make an edge out of that. The pixels that are next to each other with a similar color have a special meaning which is not preserved here at all. So this is a really terrible way to do it. But this is the way AI can do it, and that has some fundamental consequences. Your AI is doing this in a very different way than the way a human does it, so it will be fooled by changes in the image which would not fool a human. So this is the Kolmogorov-Arnold networks. These things, if you're going to fit a curve, instead of each AI contributing to every point on the curve like a high-order polynomial, you fit a sum of these things called splines that look like Gaussians, and now you figure out how much of the blue one to put in, how much of the red one to put in, and the green one, and so on. So now, if you know which neurons are controlling this amount, they're only controlling this portion of the curve. So if you have a problem at the curve, like up here at the edge, there's a fitting problem, it's not doing a good job, you know which neurons are responsible for this part of the curve. So you have more ability to control the AI and adjust it. So that's why these things are new, but they're hoping that they will turn out to be a more controllable alternative to neural nets. All right, anyway, the UK has come up with principles for the security of machine learning that are much more at the right level. So you start with your objectives and your risk assessment. Then you decide how you're going to do it, gather training data, create your model, you consider the risk. Then you verify how well it's working and monitor it. This thing that people don't like to hear from me, I say, if you're going to deploy an AI, deploy it on a small scale first and pay attention to the customer complaints. Record them, consider them. See how well it's actually working. And so you monitor it and deal with risks while it's going. and then continuously validate it while it goes. You're going to have to adjust it to try to minimize those complaints. And then at the end of life, of course, you'll have to dispose of the data in the model and remove the confidential, make sure the confidential data is not leaking out, and figure out what you've learned from this and how to improve things in the future. The UK model is much more practical for businesses. And OWASP, of course, the Open Web Application Security Project, is there for us with two good top 10 lists. Machine learning in general, they got a nice list of them here. The number one risk of AIs is evasion. Evasion is where you feed it input that has been manipulated to confuse the AI, just like you might fool a human. You could say spam is in this category, right? They send you a text message to trick you into thinking it's a real message from your bank or something, and it fools the human. You can fool AIs quite easily. You just saw me fool it with a few of those other questions. If you can control the training data, you can poison it, and then you can steal the model, the contents of the model, and so on. So this is general machine learning risks. That's a fairly useful list, but the LLM is even easier to understand, and LLMs, large language models, are mostly what people are putting out. So prompt injection is what we're about to do in the first hands-on project, where you figure out how to lie to an AI to cause it to violate its security barriers. And this is basically a form of input injection, like SQL injection, code injection. We're going to see. Then you might trust the output too much. There are various ways to express that. This is, I think, probably the largest risk in practice, like I mentioned. That'll come, there's other ones you've been through. Number 8 here, I think, should really be number 1 or 2. The problem is you have an AI, you take a cursory look at it, you see it pass the Turing test, you say, this is great. So now you fire your staff and put it in charge of a human role, or you give it the ability to do something important and dangerous, like drive a car, without realizing it's really too stupid to do that. So that's excessive agency, where you trust it to do something where it's really not up to the task, which is the big problem. All right. And so one good example is Microsoft Copilot. This was supposed to make a lot of money for Microsoft, and I'm sure you've heard everybody is sinking incredible amounts of money into developing AI. They're now talking about $400 billion to build a giant data center in the next couple of years for AI. And the question, everyone thinks there's going to be some huge pot of gold coming at the end, and everybody so far that has tried to find something to sell customers they'll pay for has pretty much failed. Microsoft can't even get people to pay $20 a month for Copilot. They're now giving it away for free with Microsoft Office in the cloud. But anyway, here's what Copilot does, which, by the way, is the same thing the Apple Intelligence was supposed to do, although it never came out, and it still hasn't come out. What it's going to do is you put it in the cloud. Copilot will look at all your data in the cloud, your spreadsheets, your emails, your PowerPoints, your PDF files and everything. And then when you ask it a question, it will use a large language model to prepare the answer. So you could ask it a question like, I need to summarize all the progress you made this month on this project. So look through all my emails and everything and figure that out and write the report for me. It'll do that. Now, when I first heard this, by the way, is what everybody I talk to in the corporate world wants. They all want not a large language model like OpenAI's ChatGPT that's trained on just all the data on the web. They want something that has access to their proprietary private company data that can help people answer questions within the context of that company data. And my first understanding of how this was done was retraining the model. And that is not how you do it. Now, this is another important concept to understand. The reason you don't do that, there's two reasons. The first thing is these models are big and huge and incredibly expensive to train. It will cost you millions of dollars to retrain the model. The second problem is really worse, is catastrophic forgetting. If you train the model on some new data, it forgets what it learned from the old data. For example, if it learned security barriers, they get forgotten. This is called catastrophic forgetting. Now, Sherlock Holmes in the fictional stories believed that the human brain worked this way. At one point, Watson told him the moon goes around the earth. And he said, shut up, I don't want to hear that. That is a useless fact. Now I have to somehow push that out of my brain to make room for a useful fact. Filling my brain with garbage that doesn't matter degrades my value as a detective. And I don't know if the human brains work that way, but the AIs do work that way. I see Sable's put up the chat. Go good. Yeah, that's right. There's a new paper that just came out about the illusion of thinking. Yep, very interesting. Anyway, so what they really do is retrieval augmented generation. They take a large language model that had been trained on basically all the data they could find on the internet, and they don't retrain it. What they do is they say this model knows basically syntax. It knows how to correctly structure sentences and paragraphs and pages so they look good, but it doesn't know anything about your proprietary data. So what you do is you have an old-fashioned search engine which they call a Microsoft Graph, which just takes words from your input and finds documents that have those words in them. So it finds relevant documents to your question, it adds them to the question, and sends it all to one of these large language models. That's why it answers another question I had. People are bragging about how our model can take 80,000 words. Well, now our model can take 200,000 words. I say, why does anybody want to put in 200,000 words of a prompt? You just want to write a question. Well, this is why. You add all this extra data, which might be whole PDF files, whole Word documents, and everything, and say, in the context of all this associated data, now answer the question, summarize all the progress we're making on the Johnson case this month. That's what it does. And by the way, if you use these large language models for free, they train on the data you send up on the queries, which is bad because they might just repeat that data back to a future person. So all the large companies do not let any of their employees use these open large language models. But if you pay for Microsoft Copilot, they promise that even though they are using the cloud model, they are not training on your data, and therefore it's not compromised. So you might want to trust them for that, although the people I work for mostly want to run a large language model on their own server to make sure that it's not going to anybody else's cloud, to make sure they know that nobody else is getting at that data. And both of those are possible. So that's retrieval augmented generation, and we'll do this in the projects. You can build your own retrieval augmented generation with Python. It's not hard, and we'll see how it works, and it works pretty well. All right. So the Microsoft provides some levels of security here, but the problem is fundamentally this. There are so many permissions, multi-cloud environments. This is the problem with all cloud security. 40,000 permissions, and the human identities are outnumbered 10 to 1 by automatically generated non-human automated process identities. Only 1% of the permissions granted are actually used. 50% of the identities are super administrators with full access to everything. This is the problem. The cloud is a mess in terms of security right now, and it's fundamentally a problem of technical debt. Now, Microsoft does, because suppose I do this. Suppose I say, write about our financial projection for the next month, what we're going to do. And you'll end up saying, well, we need to fire these people and lay off these people and outsource that division. And that is not public information. You'll have emails that say, okay, here's who we're thinking of firing, but don't tell anybody except managers. But your Microsoft Graph won't know that that was not supposed to go to ordinary people like external, and it'll make a document including that private information. Now, Microsoft offers a feature to put labels on your data and then tell it, do you want to create a public output or a private output or a confidential output or what? And it can do that, but the problem is everybody has technical debt. You have been using Microsoft 365 for years, and none of that data is labeled. So unless you're actually going to pay for somebody to go back and label all the old data with sensitivity labels, this can't avoid it. So you're probably going to leak data that you really didn't intend to leak in the output of the AI because it doesn't have enough sense to know what part of this was private and what part of this was public and what your intended audience was. So that's a big issue. And it's not really a problem with the AI. It's a fundamental problem of technical debt. Anyway, and then of course there's Microsoft Recall, which Microsoft tried to roll out, and there was a huge outcry from the security community. Now they're trying to roll it out again in a more limited form. But the idea here is this is also what Apple tried to sell everybody with the new iPhone. Suppose you had a butler that would help you with your life, that read all your emails and said, oh, you can't go to that play next week because you've got an appointment with your dentist or something. It'll notice these sort of things by reading all your email and your calendar and everything. And so in order to get that data, Recall will take a snapshot of your screen every 10 or 15 seconds. It'll record all your emails. It'll put everything in a big local database, which you can then use AI to search through. And Microsoft was betting that people would find this so useful that they would agree to this in order to get the vast benefits of having a personal assistant. And so did Apple. This is what Apple Intelligence was supposed to be, something that would understand all the data on your iPhone and help you with your life. In both cases, they have not yet come up with this product that helps you, and people have rebelled. And like I say, so far, AI, like the blockchain, is a solution in search of a problem. They can do things with AI, but there is nothing resembling a killer app yet where everybody really would want to pay for it and have it. Anyway, that's a summary of what's going on here. Let me stop this recording and make a separate one of how to start on the first project. I want to stop.